How's the sound? Just about ready. Need to get some juice. Okay, how's everybody doing today? I'm getting ready for whatever you guys want to talk about. I know somebody had a question about their file. Let me see if they posted it real quick. So let me ask them to post their config. I'm asking them in Discord for those that don't already know it exists. Okay, they haven't answered back yet. How's it going, Tim? What do you guys want to talk about today? Obviously, I'm not going to do the BL Touch because I have a space constraint, but I'm working on a way to do that. It will be coming soon. Let me see if I can show you a picture of it right now. So, this is what it's going to look like when I actually can do demos. So I'm going to have a whole printer that'll fit underneath the camera. This will be available for the patrons eventually. I'm still developing it, so it will be ready soon. So let me see what you got for questions here. Okay, Tim, can you post your config? I'll pull it up and see if we can take a look at it. Configuration.h and configurationadvanced.h. The rest I can decipher. Normally the chats or the streams start off really slow, then get very busy, or at least they have been lately. I think the problem is that I always end it just as everybody's showing up, because after about an hour and a half, I'm like, I'm a little tired, guys. So let's see what we got here. Well, I don't see it just yet, so there's a couple of resources that you can use for this. Let me pull up a web page here. Actually, I have to clean up my web pages. Give me 2 seconds. Let's see. Do I have one open now? Sorry, I've got about 10 things open in here and I don't want to make it confusing. So I'm just closing everything down. There we go. So on the web, there's some resources that you can use. So if you go over here and you start a new tab and you say something to the effect of 3D printer troubleshooting quality, I think it'll give you this right here, which is Simplified 3D's Guide. It'll talk about all the issues that you can see. Like you were seeing this overheating like issue near the top of your print. And then possibly you're seeing like layer separation. These are common things that you can see, like the little blobs. It'll actually tell you how to troubleshoot each one of these. There's a lot of things that are in here that are of use, but it should be helpful enough to at least get you where you want to go. But there might be other settings in the firmware that need to be adjusted. So if you see like shifting, that can be a lot of things. Let's see if I can find like infield gaps, the echoing. But you can see that there's a lot of different things that you can do. Port bridging, I've actually never worked with fixing that. I probably should. The warping has to do usually with your surface, possible heat, and leveling. But this is a good little guide to show you what to correct on your printer. So let me go back over to the workbench because I'm just scrolling around on there. It's been converted to a Big Tree Tech machine. So you're saying it's an Ender 5, I think, from chat. So, could you give me a little more detail as to being converted? Do you know what temperature you're printing at and which material you're working with? Is it PLA or is it ABS? Now I know there's like a 8-second delay, so I have to talk constantly to fill in the gaps. A CR10. So let's see, a CR10, I have to actually look it up because I know it's probably going to be similar to a Prusa. There we go. So I'm just pulling up an image so I can see what it looks like. And I'll let you see what I'm looking at here. So on this printer, there's probably belts for 1, 2 axes, and then there's probably a feed on the back of some kind of lead screw, is my guess. I'm trying to find a backward image so I can see it. But it looks like they're not showing the back of the printer, so I have to assume it's a lead screw. Oh, it's in front, excuse me. Or the back of the front. I'm not sure exactly which. But it looks like a Bowden tube extrusion. So the issues that you're seeing, what's the heat that you're using when you actually print? What temperature are you extruding at? And what material are you using, and has the material been exposed to a lot of environment or not. So it's got two Z-axes. Are they on separate steppers, or are they on the same steppers? Hey, David. So when you're printing, do you use like X, or excuse me, Z1, and then there's a Z2? Let me see what you said in chat here real quick. So let me go back through here. Trying to figure out which motherboard you're working with. I'm guessing that it's an SKR Pro. Okay, there it is. So are you using E1 for your second Z-axis, or are you using the Z for both of them? And I'll put one down so you can see what I'm talking about. I just have to grab one. So this is the SKR Pro version 1. You've got right here Z1, Z2. Then you can use a third one over here. I don't suggest breaking them out. I suggest sticking with just one and then using the two breakouts. But which type of stepper are you using in that? Let me read through this and see if I can see it. So are you using a TMC type stepper, or are you using a A49 or, I'm sorry, A4988 or a DRB 8825? Okay, so do you have an image of your board you can paste on Discord so I can see what it is? I understand that you probably might not have config files, but we can sort that out. My actual video series walks people through how to actually load and set up certain hardware on the SKR Pro. But I need to try and get some more information, because some of the print issues that you're seeing probably are related to its previous configuration, and I'll show you how to actually fix that. So you can print at 200 degrees Celsius. Also, the actual heat bed should be about 60 degrees Celsius if you're using it. Let's see. I can't see them. They are mounted under the power supply. Okay. It's kind of hard to troubleshoot without seeing the board or the config file. So I'll show you what I can do with this one. So setup is kind of simple, but there's a lot of things you have to concentrate on and try and do this in a stepwise fashion. So let me lock this board down on the table so it doesn't slide all over the place, and I'll start to show you the pieces to it. Now, the configurations for hardware will vary depending upon what you're working with. Let me check the view here. So it looks like I'm out of focus, so let me fix that real quick. There we go. So the first thing is the ARM processor. That's the brains of the board. It's 32-bit. Then you have your steppers. You have X, Y, Z, E0, E1, E2. Generally, E0, E1, and E2 are used for extruders. And then you have different types of steppers that you can actually use in this. So let me start pulling examples in here. I just had to read them real quick. This is the TMC 2208. With the TMC 2208, it does basically controlled stepping. so that you do it via current in the advanced configuration. Then there's a TMC 2209. This one is slightly different. It has what's known as a sense pin on it, so that if you reach the end of an axis, you don't need to use an end stop. You can actually set the sensitivity for that. Then there's other types of drivers. There's SPI. That one runs on UART, the two that I showed you there. There are different types of communications protocols. There are other types that are renamed for other pieces that do slightly different things, but they're basically TMC 2208 or 2209s for UART. So Big Tree Tech makes a TMC 2225, which is essentially a TMC 2208. And then they also make a TMC 2226, which is basically a TMC 2209. Then they make a stronger stepper. This is a TMC 5160, and this will do higher amperage, I believe, or current, we'll say for now. I have more here. I just have to find them one at a time. So there's another type of stepper that does step dir. It stands for step direction. And a DRV 8825 does that. It has a precision of 1/32 of a step, whereas this and this have 1/256 of a step. And this one might be almost the same, but it might be a little bit lower. I can't remember off the top of my head. So those are some of the things to consider with them. So I'll show you each real quick and how to deal with them. Essentially, in my tutorials, I talk about how to actually set them up. So what I need to do is show you the process that you would go through. So I'm going to oversimplify. People have seen me do this many times. So I'm going to go to first the website for Big Tree Tech, and I'll pull that up so you can see what I'm thinking about. So over here we have Big Tree Tech's website. So we're going to go to the main Big Tree Tech, and over here you're working with an SKR Pro version 1 or version 2. So you can click here, and I'm using the Pro version 1.1 right here. So I'm going to look first for the manual. Inside the manual, it will tell us how to configure stuff, or try to. So if we scroll down, they talk about the boards, what they have. They talk about the dimensional accuracy of the board. Then they have, you know, where the power inputs go, the bed power outputs, and the motor power outputs. Then they talk about each one of the devices a little bit, say where they are, and then they show pinouts. This is the bread and butter of everything. Knowing what your signal pins are, like PD8, would be helpful in setting things up. There's also RX3, but this is for UART. These are special pins off to the side, but this, and this will all do either SPI or UART, depending upon the configuration. Install guard is basically a way to find out if you've reached the end of an axis, or axi, or ax. We have the explanation of pins and stuff like that, but I'm going to jump over that. For loading software, there's two ways to do it. You can do it through 5 volts, or you can do it through the direct power. So they're telling you what the jumper position is. So I'll show you how that jumper position moves and why you want to switch it back to direct power before you set up. So they also talk about how to set up the COM port if it's not there. Usually it shows up or Windows detects it. And then they have different ways to do pins. So you have step dir. So underneath here, there's certain pins that get jumped, and they show them in little pink as to what you want to set up. This, I think, is actually incorrect. I think there was a different way to do it, but I have to go back and check that. Then we have UART. This is an advanced stepper, as well as SPI. So UART is just one jumper. So if we go over to the board, I'll show you what I'm talking about. So on the board, we have stepper jumpers here. So we need to pop those out. So usually I use a dental pick just because it's quicker for me, but you can use your fingernails as well. You take out all these jumpers because right now they're in the default position for SPI. To set up UART, it's the pin on the end that's black, and then you just push that down. So I'm going to show you a sensorless homing on the TMC 2209. So you just basically line up the pins according to the way they're supposed to be inserted. And you drop them in here. Then you take your connection for your motors, connect them over there. And we also have to set up power. And this can be a little bit of a pain if you don't know what you're doing. So always check to see where the actual connections go. And on this board, I forgot to mark the colors. I like to mark red and black so I know the difference. So I'll show you why that's important by going over to the web browser for a second. So up here, they talk about what the voltages are. So we need to know where plus and minus are. So I'm going to mark the actual board with where the plus goes. So I'll go back over to the desktop real quick. And we know that this is voltage, so we'll mark it red. That way we know and don't plug in something wrong. Then they have the next one down here as red as well. That's voltage. And that's for board power supply. Then they have the hot end, which is right here. And then finally they have the heat bed, which is here. So that tells us what's going on with the board so we don't plug things in wrong. And then if we want to get into it, we could also do these. So that's plus, 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 and then they do the opposite down here. So let me just verify those real quick. So it looks like I've got it covered according to the diagram that I'm reading on the pinout diagram over here. So we've got all those covered so we won't plug it in wrong. So let's go back to the board and I'll plug these in. We have to do both power for the board logic and we have to do it as well for the steppers. So I have to fold this up. I'm going to put in the ground first. Then I'm going to tighten this down as soon as I find a screwdriver. Then I'm going to do the same for over here. This is actually the voltage, so you can see what I'm doing. So that's the logic for this row of power. Then we have to do board logic, so we're going to plug this in. And we're going to tighten this down. Now your configurations may vary depending upon how they configure your hardware, because I've seen relays and all sorts of other things that are in there. I'm just doing the simplified version here just so you can understand what I'm doing. So once that's connected, we have to keep our power off to the side for the moment just for safety. And the reason for that is I have other things I need to configure and I have to show you how to do that. So in order to load this board, you're going to drop the drive in here. Now I currently don't have a drive here, so I'm going to steal one. And we may have to format it, but let's see what happens. So you just grab the drive, stick it in here, then plug this into your computer. On your computer, you're going to have to go over to VS Code, and my VS Code might not be configured right, so we'll do that real quick. Hang on, I got to drag it to where you can see it. Okay, so I was working on something earlier, so I'm just going to close this real quick. And I'm going to show you from scratch how you do this. So you're first going to go over to the web browser. You're going to open a window, type in Marlin Firmware.org. And this is the website where the firmware is. You go to download. Inside here, there's a bunch of little things. So as you can see, there's download zip. These are actual example configurations. They're not always good examples. So I suggest building from scratch and watching the videos just so you get an idea of what the steps are. But we're going to go over and download. Whoop, I'm sorry. I got that backwards. These are the examples. This is the actual file. So I'm going to save that. Now down here they have bug fixes. These are cutting edge. These might have issues. We discovered one the other night where homing didn't work at all. So there's open bugs on this because it's actively being developed. This is for 8-bit processors. We're working with 32, so we have to use the 2.0 version. So once that's downloaded, we're going to go over to our desktop for our downloads. And I'm going to go to downloads, and I'm going to right click on what we just pulled down, and I'm going to extract it real quick. This will take a few seconds, probably about 30 of them. And once this is complete, we can then open up that file. This is going to be a default configuration, so nothing other than a ramps will be configured in it, which is a basic configuration. We're going to have to go through step by step. So now that this is complete, we have our folder. Inside the folder, notice how there's two Marlin folders. Then there's your config over here. This is the two files I was asking for. If you know what the configurations are for them, then I can understand your configuration better quicker. So I'm going to close out of here for a second, go over to VS Code. I'm going to click on the Explorer, open folder. I'm going to go to Downloads, open that folder, then the second one, then select folder. And now it's like a regular IDE or Integrated Developer environment. So we need to find out what's going on with which board we're using. So we're going Marlin source core boards.h. We'll search on SKR Pro, and this is the version 1.0 version, so we'll copy that, 1.1. We'll then close out of boards, minimize core and source, go to configuration.h, search on motherboard. Here's the default ramps configuration. We'll paste over that. We have to set our serial port to -1. That's just the normal default way I do things. These can be flipped depending upon your configuration, but normally I do this one because that's standard, or was standard. So now we need to set up steppers. In this case, it's for an advanced stepper being the TMC 2209. So I'm going to search on A4988. This will bring us to our actual stepper section. So I'm going to remove the comment right here. I'm going to copy the TMC 2209, paste it here. That's all you have to do for that configuration. There are things you can mess around with this. This is what I was trying to ask you about your default axis steps per unit, because this will help with calibration later on. When you do the 20 by 20 by 20 millimeter cube, you may have to adjust these variables, either through EEPROM or through reflashing. I prefer reflashing because EEPROM can become confusing very quickly for a lot of people, even myself. Then you have to go over to the Configuration Advanced tab. To set this up, I'll search on 800 and show you what's going on here. So down here, we have X current. The current is controlled in milliamps. I have a default configuration, so I pretty much know what it is with the stepper motor and for the stepper. So I'm not going to compute root mean square, but this is done inside the data sheets. So you have to find the data sheet for each one of the things you're working with and then compute it. I usually go with the default, which is pretty close to being correct. A new thing that I did learn about that I usually don't encounter is when you're working with a 24 volt power supply, you have to change the power. So I'll show you that real quick. I'm going to search on 12 volts, and down here, this optimizes for when you're using spread cycle chopper parameters. At the moment we're using stealth chop. In order to enable it, you would disable stealth chop by putting a comment in front of it, but we don't care about that right now because we're on 12 volts. So I'm going to search on TMC_debug so I can show you what's going on here. So these are debug commands that you'll find that allow you to actually communicate with G-codes to see what's going on. So we're going to remove the comment for that. And there's another one that we have to do the same on, which is monitor driver status. That way we get the G-codes we want to work with. Also, we're going to do sensorless homing, which is a little advanced, but at least you'll see what's going on here. This way you won't need to use an end stop, so I'm going to remove the comment. Down here, we're actually looking for the stall sensitivity of the TMC2209. So right here, it's from 0 to 255. I normally set this to 125 because that works best for me. So after all that's configured, we also need to go over to platformio.ini and set up our board because our default environment is the SKR Pro. So we just search on SKR_Pro, and that brings us to the Big Tree Tech SKR Pro. So we can copy that, bring it up here, paste it here, and then we have to do a clean because the fresh download has the Mega 2560 sitting in there. So we're just going to clean it out with the little garbage can down here. Then we have to click the checkbox. This will do the build. Sometimes it breaks on the first time through. So if it does, hit the checkbox a second time and recompile. And usually that solves the problem unless something's configured wrong. If there's something configured wrong, then what you're going to do is you're going to have to go to the very first error and fix that one first. The other ones may be a cascade of errors caused by the first one. So let me check on the chat while this is going on because I just dumped a lot of information right there. Yeah, there might be a drive that goes with it, but not knowing what your steppers are is going to be a big deal. So let me go to .pio for a second and show you where the build is. It's in this folder under build, under SKR Pro, and then it's firmware.bin. In order to load it, you got to copy. Then you're going to go and you're going to reveal an Explorer. Actually, it'd probably make it easier. And here's the file. So we're going to right click and send it to the USB drive. Now you have a new configuration, so you're probably going to see something that says firmware.cur in capital letters. That's the firmware that is currently loaded on your drive. So you can copy that off and store it someplace, but if you ever need to reload from that, you can just basically copy it back onto your drive, and you can then say firmware.bin in lowercase, and it'll reload like normal. So let me wait for this to actually finish, but I'll go back to the directory we're in. I'm actually going to right click, and I'm going to send it to this directory in a second as soon as it's cleared out, which it is. So grab this file, right click, send to your drive. So now that that's complete, we need to go over to the actual desktop again. And I need to pop out the drive. And I'm going to actually slide it in here. Now there's a couple of ways to load it. The jumper for VCC or USB. currently I'm in VCC, which would be direct power mode. We're not using that currently. We're going to use the actual power from the USB, so I'm going to move the jumper. You remember you have to move that back after you've loaded in order for your steppers to act properly. So I'm going to grab the USB cord, and you'll see a little flashing light probably in here, and that's the firmware loading. So that little ding is good. So what I'm going to do is I'm going to power it down for a second. I'm going to move the jumper over here for direct power, plug it back in, and then power it up, and we'll see what happens. So once this is powered up, we're actually going to go into Pronterface. So let me bring up a fresh copy of Pronterface before you actually see the old one sitting there. And I also have to close another program that I have open that's interfering. Cura will grab the connection if I'm not paying attention and cause me to be confused for a while. So I'm going to pull up Pronterface for you, and we'll go over to it. So inside Pronterface, normally you can find your stepper, or excuse me, your board in here. It's either 3 or 21, I'm guessing 3. But if you can't find it, what you're going to do is you're going to use Device Manager. So if you click over here and you type Device Manager and you bring it up, you'll be able to find the actual port number that you're working with. 1 is always default, so it's going to be that, or depending upon what you have connected, something else. So we know it's COM port 3, so we're going to connect to it. And then let me bring it up so you can see it better here. So what I'm going to do is I'm actually going to move the access to see if it's working first. And it looks like it's working fine. So let's try homing. I'm not sure which direction it's going to go. So it's going in the correct direction. If that doesn't go in the correct direction, then you'll need to invert it in configuration.h. But what I'm just showing you here is actual movement on an access and that it works correctly. So that's how simple it is to set up. There are other things that are more complex, but you're at the point where you're working with your actual print. So it's probably temperature related that your issue is, but there also looks to be a calibration issue. That's why the lines might be all over the place. So it could be related to your slice and how fast you said to move the printer when printing, or it could be a clogged print head and we don't know. That might also cause strange output on the outside of your print. I know that's not a great answer, but without like information as to what's occurring in the actual configuration, it's hard for me to give an answer as to what's occurring. But we've seen the print, so I'll take another peek at it and show everybody else real quick here. So on Discord, let me see if I can move it where people can see it. On Discord in here, this is what it looks like. So at the top, it looks like if the top is the part where your index fingertip is, that looks to be a heat related issue. The other issue at the bottom, that little jagged edge, that looks like calibration, but it looks like you're getting good flow. So I'm not sure who's the manufacturer of your PLA, but it looks like it's coming out okay. You can tell that it's kind of odd in the way it looks. There might be like a retraction issue that's going on because these little globs. So I would go over to here and start going through each one of these. So this one right here says overheating. Your temperature seems a little low, so I don't think that's the case. It might be cooling. This little banding or blobs, they talk about how to look at that as well. So there are ways to actually address it. I'm hoping this answers some of your questions, but a lot of it might have to be configured inside the actual IDE. So if I go over here for a second, I'll show you an example. Let's say that you have a common configuration. I'm not saying all configurations are common. I found that out this week, that there's different gearing ratios for people's steppers, but these are the settings you're going to look at. If you measure and let's say it comes up to be, we'll say 95, and the reason that I'm saying 95 is that if you're printing a 20 millimeter cube and it's 19 millimeters, if you multiply by 5 to get yourself 100, that would give you the current size as a span of 100 millimeters. So you would take that value, go to your calculator, and inside your calculator you would have your 95 value after you multiplied out what size it was, and you would take 80, divide by 95, and that would be 84.21 because you're going to multiply by 100. And that value is going to be pasted right here. So it'll be 84.21, I think it was. And that will be the recalibration for your steppers. Now there is a caveat to this. If you go over here and you search on rep wrap calculator, they explain in detail how to set up your actual configuration. So if you have a belt driven system, so your stepper on your driver only moves 1.8 degrees per revolution, or 200 steps in 360 degrees, that would be 1.8. Your micro stepping, this is going to be a step-dur type stepper, is going to be default 1/16. Then your belt pitch is usually 2 millimeters. This would be like a GT2 belt, but they have other options that you can select from. And then your pulley has 8 teeth for a count. Then it would be 200 that you would set for this value over here. But lately, starting with 80 is the best bet because the rep wrap calculator can vary dramatically. I have seen a case where the actual stepping is not what I thought it would be because the gearing was so different. So keep those thoughts in mind because these values can move around a lot. There are a lot of little experts, or there are a lot of experts in the actual Discord that can explain this to you. So let's see. I would assume the BTT 7-inch display, TFT 70 version 3 is compatible with the SKR Pro version 1.2. I would assume that too. I don't have one. I have a 3.5-inch one that does work. The communications port does vary. So a little trick that you can use is you can actually go over to your web browser. Inside your browser, we'll go back to the tab for the SKR Pro. We can go back a directory. Usually they'll give you a little bit of an idea down in here. Sometimes they have pictures of it. So let's see if they have one. I doubt it, but it might be the JPEG. Nope, it's not there. So the other place you can check is you go to the firmware and you look for the most common one. I'm guessing it's going to be this one. Go to Marlin, config.h, scroll down to where it says serial ports, and you can see that the serial port does say that it's 1 for this particular board. The SKR 1.3 and 1.4 use 0. So this value jumps around a lot. So I could show you that I can hook up a SKR Pro with a TFT screen. I can try it on the 1.2, but I already know it works for the what is it, the 28 inch one or 2.8 inch one. That's a coming video. That's going to go into depth of a couple of things. I didn't touch using the parallel cables or the ribbon cables. I did use the TFT, but the ribbon cables will allow you to go back to the Marlin mode, so you can do other functionality on it. If you do use that, you have to have both connected if you want to still use the touchscreen. But that's a taste and preference thing. Usually I'm just trying to show you how to hook things up with the modern way that they would use it. But I found that a lot of people are now using both. So I'll start to talk about both of them at the same time in the future. Let's see, what other questions do we have today? Yeah, it does have a lot of functionality. I'm almost at the point where I want to try and hack a TFT and turn it into a Stream Deck, because I'd rather build one than buy one. But I've got 3 projects in the hopper. I previewed one for everyone that was watching early on. So here's what's coming soon. I'll have a test bed printer. This is going to be where I can show you the functionality of a printer with the motherboard just sitting next to it. So I'll show you different configurations. This is not done. It is going to be available for Patreons, but it's copyrighted, so please don't use it in tutorials. So as soon as this is finished, it's probably going to take a day to print this the way I have it set up. I'm just prototyping already, so this is going to be ready tomorrow. It's been printing for about 4 hours already, but essentially I'm going to show you on a mini scaled printer what it looks like to actually work with different things that exist on it. At present, this is still a prototype, so I don't know how well it's going to work. Right now I'm pretty sure it's not going to print good the first time. So in the future, I will have more information on this. But essentially, this is all one piece that prints. And then you can add on the top piece afterwards and stuff like that. But I won't show this until it's completed. But as you can see, it's pretty close to fully designed. I still have to add some more holes to it. I know most people aren't interested in watching me do design stuff. They just want to know how to use the printer. But this is a printer that I have to design in order to make life simpler for people to watch due to the, we'll say, space constraints in where I'm filming. This will at least illuminate some of that functionality. So let me take it back to the workbench because I don't want to show you the prototype for too long. See what we got for questions here. I'm using OpenSCAD to design it. It's a very simple program to design in. Unfortunately, I don't want to show people all the source code to what I'm doing, but it's more like a programmer utility than a drawing utility. So that's the one I'm most comfortable with my background. That's why I do that. So it's very C-like to me. But I can show you examples of how to use it, but there's videos out there. I have, I think, a series of 10 of them that I did some lazy afternoon a couple years ago that show you how to set it up and use it. It's not hard at all. Then the more complex stuff, I mean, it gets very complex very quick. I use a lot of translates to move things around. This is positional stuff. But obviously I'm looking at the desktop instead of showing you what I'm talking about. So I'll show you an example real quick in OpenSCAD. If you go over to OpenSCAD, you can draw a couple things real quick. So we'll do a cube. just put brackets inside. This is X, Y, Z. You have to end it with a semicolon because it's a statement. The actual size of this, whoop, I put an extra comma. We'll say it's 10 by 10 by 10. All you have to do is press render, and that gives you a cube. If you want to cut a circle out of that cube, it's really simple. You can do difference. And the second thing is the thing that subtracts from it. So we'll do cylinder. And we'll say the cylinder has a diameter of 10, a height of 10. And we'll say that the roundness or number of facets is 30. You can go much higher, but this will render quicker. And then you hit render. It's actually combining them right now, so I may have misspelled difference, or I may have forgotten to put this inside here. There we go. So that's actually cutting out something. So I do this in various combinations. I can move this cube around by saying translate. This says where it is positionally in space. So if I want to raise it up 10, I can just say that. I can take this. This is actually a function of translate at the moment. And these are a function of difference. And watch. So that's how I build objects. There's some more complex stuff that I do in my actual models, but most of it I cover in the tutorial series. So hopefully that is helpful in designing your own parts. Let me see what the chat's saying. It's not really an adventure, it's more like a journey. Just remember to take your time and do it step by step. So if your print's not working, change one thing, do a print, verify it, fix what needs to be fixed, then change another. If you do it all at once, it'll become very confusing very quickly. You're still getting the no printer attached, David. Inside your firmware, does it say that your serial port is 1? And then on your TFT display, does it say under settings what speed you're actually communicating with your board? So I'll show you a quick example. Let me just power down the system real quick. So there's two things that usually cause the no printer attached message. One is unmatched speed. The other one is the setting for the second serial port. So I'll show you that one first. So if I go over to the desktop real quick and I pull up the configuration, I'll search on motherboard. Up here, if this isn't enabled, it won't communicate, and this has to be 1, I believe, in the case of the board that you're currently working with being the SKR Pro1.1 or 1.2. Let me grab a display real quick here. And I also want to point out that your baud rate also has to match. So I'm going to go quickly over to the browser and find out what's going on with the actual display that I have. So if I go back here, I have to figure out where it needs to be actually connected. Now I actually know it, but the reason that I go over it every time is so that you can see how to search for the information, because I actually want you guys to teach me someday when I don't know what's going on, which seems like every day for me. So let's go to schematic. No, that's not going to be helpful. Most people have a hard time reading that, even myself. Let's see, manual model. we'll go to model. We'll look for what says pin, because this is pin out. And down here for the TFT, we're looking for reset. That's the only pin we care about right now. So we'll go back to the workbench. When you connect this, you can connect it backwards. I don't suggest it, but I'm just trying to show you the thought process. So these sit side by side. So I'm going to put these ones here. Then I'll put this one in the reset. And then to test it, we can power up the screen by moving the jumper over and to power for USB and power it up. And it looks like it's coming up correctly. So it does say no printer connected or attached. So we've got to first try plugging in. It's probably not going to work if I plug this in. So my power supply is awfully quiet, which is a little nerve-wracking. Oh, I know why. I need to power that down for a second. Move this over. Plug this back in. No screen. Now we'll power it up. Still my power supply is quiet, but okay. So, no printer attached. One of the first things you can check for is settings. Then you're going to go to connection. Then you're going to go to baud rate and verify you're set to the right connection. If that is correct, then it's probably the setting in the firmware. So I'm going to put this down. I'm going to power down the system for a second. I'm going to pop out the drive and put this in the computer on the thing that we were building. Once that's connected, we'll go over to VS Code or desktop, excuse me. And inside VS Code, we'll go to our platform IO. We'll go to firmware.bin, reveal and explore, right click, and we'll send it to the E drive. And inside the E drive, you can see the firmware.curve from the last build, and this is the new one. So if I go back over to the desktop or the workbench, pop out the drive, pop it in here, connect this up, then connect the power. It shows up. So that might be one of the two issues that you're seeing. Try that, let me know. One of these days when I can afford it, I'll order a bigger display. But for the people that are tipping and super chatting and stuff like that, thank you very much. That helps me afford hardware to show you stuff and offset some of the cost of my time. But obviously it's mostly hardware for me. So let's see what we got going on in the chat. Funny thing is, M122 gives report on screen. Yeah, if you're doing it via the display, you can see it. The display is like a mini computer, emphasis on mini, but I'll show you guys that real quick if you want to see that. So if I go over to the screen, I'm gonna have to plug in the setup real quick here. So when this comes up, what he's talking about is on the screen they have a terminal window, and you can go M122 and you can send it and it'll give you a readout in theory. There it goes. So that kind of went by really quick, but that was the stepper it was talking about, being this one being okay. That's the same thing I do in Pronterface. But I like to show in Pronterface because it's a great analytical tool. And also you can send, what you see on the screen over to somebody else to troubleshoot or take an image of it. For instance, if I go over to Pronterface right now I'll show you some of the functionality. This is not used very much by anyone anymore, which is okay. It's free, but if you connect to the device, you'll see a readout. You'll also have the ability to set up debug communications so you can see even more detail. So I'll show you an example. I'll plug this in and we'll see what we get for detail. So if I plug in the power supply and I connect to the board, you can see the printer is now online. And now you're seeing debug information that's being sent back and forth. This is actually just checking temperature, which is over here. Obviously it's not a great display, but that's okay. We don't really care because it's also written right here. Then we can do the M122. And now we'll get mad information about the steppers. Now if we do a M119, we can actually check to see what's going on with the end stops. And if we want a home, we can do, what is it, G28, I think it's X. So there's multiple ways to control your printer and verify that the commands coming from your G-code files actually work by just pasting them in. That's what's great about this little thing. You can also move your access around and you can test temperatures and see what's going on here, and if you have errors you can find out what they are over here. So that's why I like Pronterface. It's a good tool for doing analytical things on the printer. If you were to use something like let me see if I can pull this up. Actually I don't have it up yet, so let me see if I can put it in a screen you can see. So we go to Octoprint. Oop, wrong Octoprint. Granted, you won't be able to see this address, so I think it's 5 or it's 6. Okay. So right now I have a print going, but you can monitor the print. The terminal over here is pretty good. It will respond back, but if you're using Cura, it doesn't respond back very easily. So that's why I like it, so you can see what's going on and you can get information from it. So you can also filter this. Now you're not really seeing anything about temperature, but you can basically suppress all these windows, hopefully. It's been a while. I don't want to mess with it too much because I'm into 4 hours of a 20-hour print, which is not going well because I use bad filament. So that's just what I'm currently working on, is that little prototype you're seeing. Let me go back over to the desk. Let's see what we got going on here. Octoprint functions like a computer. So it's a mini PC. Essentially, it's a great way to offload some of the duty cycle that's occurring on your computer to another device. So all it's doing is sending G codes one at a time to the actual device. So it's more like a queue of commands. In this case, I could run it off this computer. The problem is the noise in the room that I'm in versus another room. And I can communicate with it via Wi-Fi on the, what is it, Raspberry Pi 4. The one that I have can process Wi-Fi really well. And also could possibly slice, but I haven't played with that functionality. And I know people have been asking about that other software, was it Clipper? I haven't had a chance to actually sit down and go into Clipper firmware, but I hear people asking about it all the time. So I might start playing with it on one of my boards just to see what happens. But there's no guarantees I'm actually going to do a tutorial on it right away, because the moment I do a tutorial, it's like the assumption I know every single thing about it. So I'd like to know as much as possible before I actually post anything. But I'm sure somebody's going to get inventive and post a video soon on it if they haven't already. But I've got at least 4 or 5 weeks of work that I got to get caught up on for YouTube, because the last year I've spent making sure that work can do their work. That's the best explanation I can give on the subject. So I haven't had a lot of time for videos because I've been making thousands of things. But at least now I have about 5, 6, maybe 15,000 hours on the Ender 3, because I have several of them now at work. But that's just because that's the tool of choice and least amount of work to work with. Let's see, GTR serial port, TFT is serial -1, and serial 3, I believe that's correct, but I'd have to check. Also check your speed. But I think you were asking originally about, nope, I'm getting you confused with somebody else. Sorry about that. GTR will be different. It's a different serial port. Let me see if I can find something in the web browser real quick here. So if I go over to the desktop and pull up the browser, we could probably find something on the GTR here. There's a couple of techniques. I just showed you the earlier one, but it's repositories, GTR. Go over to here. Then there's possibly something in here under pictures. I look for the JPEGs because that's usually when someone does that, but it's not there. So it may have been some other source that I found it at. Operating instructions, it's probably not in here. Oh, this is the manual. So the next best place in GTR folder is firmware. Then you can go for the default configuration, hopefully. Or this, it's got a TFT in it. That's actually a bin, so that's not going to help us, because I'm not going to show you how to decompile. So we'll go to the next one. So demo, configuration.h. Scroll down. They say it's 1. I don't know if that's true. It might be 3. So there's no guarantees, but it's probably one of those two. And they also set this to 115, 200. You can go with this and possibly even this, but they like to set it to a default that almost everybody uses. But I believe I did a tutorial where it said 3. We could probably test it. So let me disconnect this real quick. I gotta wait for the capacitance on this board to drain. That's when the LEDs all go out. Pop this out for a second. Disassemble this. Let me just reset it back to what it was, and I'll grab a GTR just so we can test this. Now I will be getting new boards, as you've already seen, the SKR 1.2. Those ones I generally hold off on showing during live stream because people want to see tutorials first. So I'm probably not going to show everything functionality wise on the board until it's in the can, meaning recorded. So let me get this out of the way. And for those that don't know, next week there might not be a Friday and Saturday stream. I'm getting my second shot, and I've been warned that it might be somewhat reactive, meaning I might feel like I have the flu. So I'm probably not going to be on Friday and Saturday next week. Depends upon how I feel. But I will be on Monday. And then in a couple of weeks, I might start trimming down the streams, only because the heat gets intense in the summertime here. So I might ask you guys to pick a day that you like to see a stream on, be it a Monday or a weekend day that's most convenient. But for now, I'm probably going to do regular streams until the temperature changes. Right now it's only 70 degrees out. When it gets up to 80 or 90 degrees, it becomes unbearable to talk. Or you'll see me sweating over the board, which is another possible danger issue. I might move it to an early morning slot. So there's the board. Let's test this theory out. So we're not going to really worry about steppers. Whoop, sorry. There's the board. So if we go over to VS Code on the desktop, we're going to make some mods real quick. So we'll start with 3 just to see what happens. The board we had to find, so we're going to go to .pi, or not .pio, but go to Marlin, source, core, boards.h, search on GTR underscore. There's our board. Copy that. We'll minimize this. Go back to configuration.h. We'll paste that configuration in. And hang on a second here, I made some kind of mistake. Oh, I copied the whole thing. So that's the chipset they're talking about. Now that that's complete, we're going to have to load it the same process. So I'm going to have to grab a SD drive someplace because I left it in the other board. So I'm going to try and build it. It's probably going to fail. And the reason it's failing is because I didn't set the platform.io.ini. So this is going to go on for a second. So we'll go in here, we'll search on GTR underscore, and here's our configuration. So we'll copy it, go up here, paste it. We'll do a clean this time. Then we'll do a build. Did the build not register? No, it didn't. There we go. It may fail again. And it did, so let's try it again. Okay, so this is probably a real failure. So let's see if we can sort out what it is. I'm gonna have to take a break for about 1 minute. I'll be right back. Sorry about that, I had to pay the water bill. So, the failure in this case, we're going to go to the very first failure. If we can see it. So, missing binary token. That's correct. Let's go back over to configuration.h. Inside here, that looks correct. So let's first change this or comment this out, see if this is the issue. So we'll comment that out. It still fails, but that might be a clean issue. Or there might be a broken build. But I don't think it's a broken build because I think it's still the same version. does say something about COM port 1. So I'm going to close this. And that shouldn't be COM port 1 anyways. So that's just something weird. Interesting. So in this case, I'll show you what I do to deal with this if I'm having a confusing issue. Is I'll click on close file folder. I'll go to my main folder, go to my downloads. I'll delete all the ones that I know are broken, and usually I'll download it again and reuse it. So I already have one here, so I'm gonna send this or extract this. And then I'm gonna double check Marlin's website because I have a funny feeling maybe a new version came out and it's broken. Nope, it's not a new version. That's still the same version. So as soon as this extracts, we'll just go and reopen it and rebuild it and see what happens. There might be a setting that I'm not aware of. It's kind of hard to scroll to the top when it won't let you scroll to the top. But I believe there is a file that you can open to find it. I just don't know what it is off the top of my head. So we'll go in here, we'll reopen this as a brand new file just to see what's going on. We'll go over to Marlin source core boards.h, search on GTR. We'll verify that we've got the right GTR because maybe I copied the wrong one. So GTR underscore BTT, copy that, minimize, configuration.h, search on motherboard, paste it, -1. We only care about the LCD, so we're going to remove the comment, change it to 3 for the moment. That's all we're changing. So let's go over to platformio.ini, search on GTR, copy this, go to the top, paste. That's all we need for our settings at the moment. Trash the previous setting, build. So there might have been something corrupted. Don't know. Don't give it too much thought in my case. It's a good thing to back up your builds by folder in case you know what the last good point was, or use source control. In source control, I mean something like SVN or Git. But that built fine, so let's go over to .pio. Find it in here, right click. We're gonna go to Reveal and Explorer. And I don't have the drive connected yet, so I gotta do this real quick. So I'm gonna go over to the camera in a second. I got the drive right here. Actually, I got the drive right here. It's already in there. So I'm going to drop it into the computer. Go back over. Right click. Well, actually, let's go to the drive first. I'm just going to leave that alone because it doesn't care. And I'm going to send it. But if in your case, you may want to back those up once you load it so you know what your last known good configuration is. That way you can just reload it if there's a problem. So I'm going to pop this out. And I'm going to place it back in here. So we're going to be on USB power for this test. I gotta double check the TFT. So I'm gonna go back over and see what's going on with that real quick. So it is right here. Let's go back, and back. So firmware GTR, manual, pins. So down here, the TFT, the reset's on the right-hand side. So that means we've got to rotate this around, and we're going to come in like this, and then we're going to take this one and slide it in by itself, and we can double check when we're loading the firmware. So we'll just plug it in. Whoop, you didn't see what I did, sorry about that. Let me show you real quick. So we're gonna slide the big side in first, then we'll do the reset over here, and then we'll power it up. And the firmware should load at the same time, and we'll see if that number works. And that did. So the number is the one I just used, which I think is 3, and it came up fine. Let me double check. Let's go over to the transition over here. So right here. So those are the settings that you need to set in order to use the Big Tree Tech TFT display on that. Okay, well, it's getting kind of late. I've gone over my normal hour. Let's see. Let me read through some of these comments real quick. Yeah, I can make that, but the best way to control the quality is to basically keep it in a container that's closed with like a bag of rice in it. That keeps the moisture content low, or use it quickly. In the case of work, I use it quickly. So, for those that have been doing super chats and I didn't see them, thank you very much. For those that are paying on PayPal like last night, thank you very much. There was somebody last week that wanted me to mention them, and I am thankful that they sent a payment via PayPal. Let me see if I can find their first name real quick. Sorry, I have to go search because I get a million messages a day, so not literally a million, but let's just say a significant number. So this person was, well, I'll thank both of them that just did it in the last couple days. Jack, thank you very much. And who was the other person? Sorry, there's several that I have to go through. Is Julene or Jeline? I'm not sure if it's the correct way to pronounce her last name, but it looks like Julene. It's probably Julian. But both of you, thank you very much for the PayPal donations. They're greatly appreciated. Eventually, I want to put those up for also Patreon at the end of the video. But I'm still working out the content for Patreon for everyone. But there is already, I think, 10 videos up there that I put last week for patrons to see before they come out. And there will be obviously projects going up there. I have to put them up there because last time I did a printer design, it ended up turning into the Creality and I didn't get paid for it. So I like to keep my designs a little bit close to the vest now. So thank you very much for taking the time to watch, and take care, get your shots, wear a mask, and be safe.